All right, intro to sequences and series, okay? So close to summer, we're almost there, guys. Okay, so sequences. A sequence is a list of things, usually numbers, and they can be in any order. It doesn't matter, but so it'd be like 3, 5, 7, 9. This could also be like 2, 5, 8, blah, blah, blah. It could be like 1, 2, 6, blah. Like it could be just any list of numbers is a sequence. Okay, the sequence is the list or terms or elements or whatever it may be, okay? So a sequence is a set of numbers with a particular order or pattern, and each number is called a term. Some people call them elements or members. They all mean the same thing, okay? So there's a difference between a finite sequence and an infinite sequence, and it's really important that you get these in your head. So first, let's think, what's the difference between finite and infinite? Well, finite means like it ends, like there is an ending point, we get there. Infinite means it goes on forever. So like we are adding these things forever, okay? So what I just said, a finite sequence is a sequence with a limited number of terms, whereas an infinite sequence is an unlimited number of terms. It just goes on forever and ever and ever. Okay? So like here's examples. So finite means it stops. So we go like 100, 99, 98, 97, blah, blah, blah. We're done. Infinite, like we go 3, 6, 12, 24, 48, 96, 1 something, and it just goes on forever. If it has dots at the end, that tells you that it's going to continue forever, okay? So here's some more examples. So like 1, 2, 3, 4 is a simple sequence, and it's an infinite sequence, whereas like 20, 25, 30, 35, also infinite, we're just adding 5 each time. Whereas like 1, 3, 5, 7 is finite, it stops. Okay, 4, 3, 2, 1, again, finite, it stops. 1, 2, 4, 8, 16, 32. We're doubling each time, but this is infinite because you can continue to double it, and we decided to do so. Whereas A, B, C, D, E, they're alphabetical, and it's just the first 5 terms. Finite, it stops, okay? F, R, E, D, it's the name Fred. Finite, again, it stops. Whereas like 0, 1, 0, 1, 0, 1 is alternating zeros and ones, but it goes on forever. So that one would be infinite. Okay. Okay, so let's get into some term notation. So the first term in the sequence is always denoted A sub 1. So like if we're given that A sub 1 equals 3, that means the first term is 3. Okay, and for each subsequent term, it's denoted A sub n. Whereas like, so the second term would be A sub 2. The third term would be A sub 3. The fourth term would be A sub 9. And that's like, these are the same as over here. So I got like A sub 1 is 3. A sub 2 is 5. A sub 3 is 7. A sub 4 is 9. Which means like A sub 5 would be 11. A sub 6 would be 13. And blah, blah, blah. Okay. Cool beans. Okay, recursive formulas. Now I'm going to ask you in the quiz, like, what's the difference between recursive and explicit? You're going to have to tell me. Okay, a recursive is where you have to use the previous term to generate the next term. So that means we're looking at our previous terms to figure out what the next terms are. Okay, so if I have negative 8, 3, 14, 25. Well, first I need to figure out what's going on here. So my first term is negative 8. And then if I look at this, like negative 8 to 3, I add 11. 3 to 14, I add 11. 14 to 25, I add 11. I'm just going to keep adding 11. So that means I am adding 11 each time here. Okay, so I can use you have to use the previous term here to figure out what that next term is. Okay, so the way that we're going to write this is A sub n. So this is denoting like any term here, or the nth term, whatever that is, equals the previous term. So the term right before the nth term plus 11. So I could plug in any number here. So like if I wanted to find the fifth term, that would be A sub 5. And then I'm plugging in 5 for my n's here. So A sub 5. This would be 5 minus 1, which is 4, plus 11, which I don't know what A sub 5 is, but I do know what A sub 4 is, because this would be A1, A2, A3, A4. So A sub 4 is 25. So that means this is going to be 25 plus 11, which is 36. Okay. So let's go through some examples. So if I'm given that A sub 1 equals 6, and A sub n is 2 times A sub n minus 1, so times the previous term, minus 5. And I want the first 5 terms in the sequence. Well, I can find A sub 2, so that's 2 times the previous term, minus 5. A sub 2 would be 2 times A sub 1 minus 5, so that's 2 times 6 minus 5, which is 12 minus 5, which is 7. A sub 3 would be 2 times 7 minus 5, which is 14 minus 5, which is 9. A sub 4 is 2 times 9 minus 5, which is 18 minus 5, which is 13. And A sub 5 would be 2 times 13 minus 5, which is 26 minus 5, which is 21. So those first 5 terms there are 6, 7, 9, 13, 21, blah, blah, blah. Okay? Now this one over here, so A sub 1 equals 3. A sub 2 equals 4. And then this formula over here is saying A sub n, so our nth term, equals A sub n minus 1, so the term right before that, times A sub n minus 2, so that term right before that. So we're multiplying the 2 previous terms together to get that nth term there. So if I want to find A sub 3, well, that's going to be A sub 2 times A sub 1, which is 4 times 3, which is 12. If I want to find A sub 4, that would be 12 times 4, which is 48. If I want to find A sub 5, that's going to be 48 times 12, which is 576. So this is blowing up. It's going to get really, really big. But our first 5 terms are 3, 4, 12, 48, 576. Okay, there's all sorts of patterns that you can come up with here. All right, so those are recursive. Now let's get to explicit. So explicit, it's a rule in which the nth term is defined as a function of n. So you don't need previous terms here. We're just doing it as a function of n. Okay, whereas recursive, you had to do it based on the previous term. Here it doesn't matter what the previous term is. We don't even have to know it, okay? So if I'm given A sub n equals 7 times n minus 3, and we want to find the first 5 terms, well, I can just start plugging in 1, 2, 3, 4, 5 for n. So like A sub 1 will be 7 times 1 minus 3, which is 7 times negative 2, which is negative 14. A sub 2 would be 7 times 2 minus 3, 7 times negative 1, which is negative 7. A sub 3, 7 times 3 minus 3, which is 7 times 0, which is 0. 4, 7 times 4 minus 3, 7 times 1, which is 7. A sub 5, 7 times 5 minus 3, 7 times 2, which is 14. Cool. So I have negative 14, negative 7, 0, 7, 14, blah, blah, blah. Let's do another one. So if I'm given A sub n equals 1/3 to n, the power is n plus 1. So I can start plugging in numbers. So if I plug in 1, I get 1/3 to the power of 1 plus 1. So that's 1/3 to the second power. Which if I square that, that's really 1 squared over 3 squared, which is 1/9. I plug in 2. That's 1/3 to the third power, which is 1 over 27. I plug in 3. I get 1/3 to the fourth power, which is 1 over 81. I plug in 4. That's 1/3 to the fifth power, which is 1 over 243. Plug in 5. That's 1/3 to the sixth power, which is 1 over 729. Okay, so our first 5 terms are 1/9, 1/27, 1/81, 1/243, 1/729. Cool. Okay, series. So that's sequences are just lists that go on forever, and they have some way to get these numbers or terms. A series now. So a series sounds a lot like a list of numbers, but it's actually when we start to add them together. Okay, so the series, when we're actually going to find, it comes to a single term, okay? So series is the sum of the terms in a sequence. You add them up. Sum means addition, okay? So if I want to find the series of the sequence 1, 2, 3, 4, well, I can just add 1 plus 2 plus 3 plus 4, which is 10. So the series is 10. If I want to find, it's easy. If I want to find the series of the sequence 3, 6, 9, 12, Well, that's going to be 3 plus 6 is 9, plus 9 is 18, plus 12 is 30, plus, well, the next 15 would be 45. This number just keeps getting bigger and bigger and bigger and bigger and bigger, right? We're never going to reach an ending point. You're just going to add forever. So that means that when we add all of these infinite terms here, it's just going to blow up to infinity. Which there's a term for this. That means that it is diverging to infinity. Okay? Infinity. Okay, so then if we have this sequence, 1/2 plus a 4th plus an 8th plus a 16th plus blah, 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 blah. There's this, it's called Zeno's paradox. And he talks about like, hey, if I'm walking to the end of a street, I have to walk halfway there. And then I have to walk a quarter of the way there. And then I have to walk an 1/8 of the way there. And then a 16th. And then a 32nd. And then a 64th. And blah, blah, blah. And so on. So if I keep walking that distance, I'm walking an infinite number of distances, right? But eventually that distance gets so teeny, teeny, tiny that we're going to get there. And so this actually is going to add up to something. Because here, so we have a half. So if we just started with this square here. Or another way to do it, I'll draw a circle. So if we start with a circle. When we take half of that circle, right? And then I'm going to take a 1/4 of that circle. And then I'm going to take an 1/8 of that circle. And then I'm going to take a 16th of that circle. And then I'm going to take a 32nd of that circle. And then I'm going to take a 64th. And I'm just going to keep doing this. What is happening here? Like, it is eventually going to just, I'm going to have the whole pie filled out, correct? That's the same thing that this picture is showing. So that means that this sequence, when we add all this together, is actually going to 1. Okay, this is an infinite sequence that is going to converge to 1. Okay, converging means it goes to a single point, whereas diverging means it goes off to infinity or negative infinity. So like that one diverges, whereas this one converges. Okay, this stuff is really important in calculus, actually. So when you guys get into calculus, it's a little higher up in calculus, but this stuff is important, okay? So if it goes to infinity, it diverges. If the sum goes to a number, it converges. Okay, so let's look at partial sums. That's what we're going to do today. So a sum of a specified number of terms, so it would be like S sub n, where n is the number of terms. So if we're given this sequence right here, 1, 2, 3, 4, 5, dot, 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 and we want to find S sub 9. Well, that means I need to add up the first 9 terms. So the first 9 terms here would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you can look at this and see that you're adding 1 each time. So then I'm going to do S sub 9 equals 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Add all that together, you get 45. Okay, if I have 1, 4, 9, 16, 25, and I want to find S sub 6. Well, first I need to figure out what the heck is happening here. Well, A sub n equals n squared. Because if I do 1 squared is 1, 2 squared is 4, 3 squared is 6, 4 squared is, it's not 6, I lied, sorry, I can do math, I promise, is 16, 5 squared is 25, let's just go one more, 6 squared would be 36. Okay, so that means I'm going to add up those first 6 numbers, 1 plus 4 plus 9 plus 16 plus 25 plus 36, which is 91, okay? On to bigger and better things. She looks a lot like Angelina Jolie. Yeah, whatever. Lots of people disagree with me, but I think this lady looks like Angelina Jolie. Okay, anyway, so summation notation. So a way to represent a series is by using the Greek letter sigma. So it looks like an E, and it's used to denote the sum. So like if I have the sigma from n equals 1 to 5 of 2n, so that's saying the sum from n equals 1 to n equals 5 of 2n. So the way you do this is the bottom term is your starting term. The top term is the ending term, and then that's the formula for our sequence. So if I want to find the sum to this series here, I'm going to plug in the bottom term. So I'm going to plug in 1, which is where I get this. And then I'm going to do all the numbers between. So then I get 2, 3, 4, and then I'm going to go plug in the top term, which is where I get 5. And that's where it's like, okay, I'm done. I'm stopping there. Okay. So then this is going to be 2 plus 4 plus 6 plus 8 plus 10, which is 30. Cool. So let's do these ones. So if I have m equals 2 to 5 of m squared minus 1. Well, that means I'm going to plug in 2, 3, 4, and 5 and add them together. So 2 squared minus 1 plus 3 squared minus 1 plus 4 squared minus 1 plus 5 squared minus 1. Which is 4 minus 1 plus 9 minus 1 plus 16 minus 1 plus 25 minus 1. So it's 3 plus 8 plus 15 plus 24, which is 50. Okay, let's do this one. So if we have a number on the outside, so 3 times the summation of 4 from 4 to 8 of 4 minus p squared. Well, I'm going to keep the 3 on the outside, and I'm going to plug in 4, 5, 6, 7, 8. So I have 3 times, and then I'm going to do the big bracket. So 4 minus 4 squared, plus 4 minus 5 squared, plus 4 minus 6 squared, plus 4 minus 7 squared, plus 4 minus 8 squared, which that's going to be 0 squared, negative 1 squared, negative 2 squared, negative 3 squared, negative 4 squared. So that's 3 times 0 plus 1 plus 4 plus 9 plus 16. If I add all those numbers in the parentheses together, I get 30. So 3 times 30 is 90. Okay, so you do the summation first and then multiply it by whatever number's on the outside. Cool? Okay, that's it. Bye.